Well, thank you, Shauna, and thanks everyone for being here. This was an interesting presentation when Shauna approached me about doing something for this group relating to data. We've been looking at different sources of data, and as a community, especially through VSP, we've been wrestling with the issue of using data to make decisions to show that voluntary conservation is having a beneficial effect at the watershed scale. And that's been a real challenge for us. Some folks are finding that data they thought was going to work really well isn't. They're finding it's really hard to collect their own data. And that's just on the technician side. And so from a leadership side, we started thinking about how does somebody that's in a leadership position know they're looking at good data, or know that when somebody brings them a study or a report, that study or report is based on good data, because as we'll discuss, good data leads to good decisions and poor data leads to poor decisions. And so we're kind of going to take you down through a path of talking about data in general and data quality. And come on, click, there we go. What that means. We're going to talk about metadata and what that really is, not what the popular rhetoric has been about metadata. We're going to talk about some examples of that and have Levi present you some about how you might ask a question and look at how the data in front of you compares to your question, and then we'll talk about some sources. So that's hopefully where we're going to end up today. As I mentioned, data quality is important because we make decisions based on data, and the better the data and evidence, the better the data decision. I tend to dabble in the data and information world on the left-hand side of the continuum, and a lot of people deal in the knowledge and wisdom side. And so hopefully what the data junkies are doing, or the data people that are providing that to you, is providing you with good data. How do you know you're looking at good data? You've heard scientists say, well, the data supports this conclusion. Well, the problem is data is on a continuum between good data and poor data, just like a lot of other things in our world are. You've heard the expression on the right, garbage in, garbage out. That doesn't apply just to computer programs. That applies to data collection and decision making that's based on that data. And me personally, I would like to make decisions based on good data because it's really expensive and messy and all that when you make decisions based on poor data. So let's look at what makes good data. So if you dig into the interwebs, which is knowledge of all things, and or data scientists study guides, you find that there's varying lists of what makes good elements of data. This was a fairly simple list that we selected to base this presentation around. Notice it's not just one thing that makes up data quality. We have to ask if the data is complete. We have to ask if the data is timely. We have to ask if the data is valid. We have to ask if the data is relevant. We have to ask if the data is reliable, and we have to ask if the data is accurate. And the problem is we tend to get focused on one of these elements and ignore the others. And so what I want to do in the next handful of slides is walk through these elements and actually translate them into something that is meaningful. So with that, we'll start in a random place. We're going to start at reliable. And essentially what reliable is saying is the data repeatable? If I did the same exercise to collect the data, would I get a similar set of data? And did whoever collected the data describe their methods? Because a lot of times we'll find out they don't. So reliability is about repeatability. Validity. Validity is really about did the data scientists make a mistake? And or did they follow an accepted method? And so there's lots of places for scientists to make mistakes. Unfortunately, we're human and we do. We can do it at the data collection phase. We can do it when we're sorting the data out to decide if all the data meets a certain quality standard or not. We can mess up the sample collection, we can mess up the data analysis, and we can certainly mess up the conclusions that are based on the data. So in order to be valid, we have to get all those pieces right as data scientists in order to hand that off so you have valid data to make a decision about or with. We have to decide if it's accurate, and what accurate really means is the data good enough for my question? And in the data world, we talk about accuracy and precision. Precision is really the repeatability. Accuracy is how well the data set mirrors reality. In this case, the set of dots is a set of data collected. The real answer is in the bright green center of the bullseye. The set of data that was collected is not. Given how good we need of an answer we may not need super accurate data. This may be good enough, and we have to understand that by understanding our question, and we'll dive into questions as we walk through some examples. So that's what accuracy is about, and again, accuracy is relative. Speaking of relative, relevance. So what does relevance mean? So really what it means is, for my question, because data is hopefully trying to answer a question, is the data appropriate? So we need to ask ourselves if it's measuring the same thing or a similar thing, in the same units, in a similar time, in a similar geography or space, and are we really getting an apples to apples comparison or an apples to oranges comparison? And last, almost lastly, completeness. Completeness means, does the data tell the whole story? And I put this picture of an elephant here to remind us that a lot of times we get a hold of a set of data and we're looking at the leg and making a conclusion based on, or making a decision, even worse, based on the part of the elephant that we're holding on to. And so in this case, I've generated some mythical data. In the upper graph, I clipped out a section in the middle. And what might I conclude by looking at this trend? Well, it goes up, something happens, and then it has a little dippy and it comes back down. If I include the data, and it's just a math equation to generate the data, in the lower graph, all of a sudden I noticed that whatever this thing was that we were measuring absolutely tanked in the place that the above graph would say it's missing. And so what I need to ask is the data telling the whole story? And I might come to two very different conclusions depending on which set of data I'm looking at in these two charts. And completeness. The last thing about completeness is there enough data? So this is as close as I'm going to go to math. The thing to focus on is the brown line in the bottom and the purple line at the top. In this case, on the brown line, I have a very small sample size and I have a 10% margin of error. Maybe that's good enough for the kind of question I'm answering or the kind of decision I need to make. In the top graph, I have a sample size many times bigger. I'm not going to do that math in my head or in public. And I have a much smaller margin of error. And so when we look at data that's collected has lots of sources of variability or lots of room for error. And we need to know how much of it was collected in order to overcome that variability. And timely. So is the thing that was measured subject to change? So I'm looking at a data set from 10 years ago. Meanwhile, a flood happened, or climate change has occurred, or. And so when I'm looking at a set of data, is it still in the same time frame as the thing or the question I'm asking or the data I'm trying to collect to compare it to? So those are the elements really quickly and hopefully really simply. How do I know the data has all that stuff? That's the big question. And the answer is a 2 4-letter word called metadata. And I've heard different uses of this in the news and popular reporting, but really, as a data scientist, metadata is data about other data. Okay, how does that work? What it's really doing is describing the conditions and describing all of those qualities that we just talked about. So it should tell us about the purpose of the data. Why was that data collected? So when you're evaluating that data set, you can then see whether it's relevant to your data or not. The metadata should tell you the time and date the data was created, so you can understand if the data was timely relative to your question or not. The data should tell you what standards were used or what methods were used, so that you know if the data is valid. The data should show you the data quality, so you know if it's accurate. And it should show you the process used to create the data, so you know if it's complete and reliable. And in many cases, metadata will also describe some of the limitations, so you can also tell if your data is reliable and appropriate for what you ask. So unfortunately, metadata is not standardized. It comes in many, many, many forms. My background with metadata is more in the spatial realm. So we'll start looking at metadata there. Usually it's pretty easy to find. In this case, we're looking at a Washington DNR, GIS open source data. If I look at the data set menu on the right where it says download, I can download at the bottom of the list the metadata. And in the world of spatial data, there are some standards set by the Federal Geographic Data Committee. There are various evolutions, and we'll look at some pieces of that. And so if we go to this DNR data and open the metadata, we start to get things like this. A summary of the data. So now we know why it was used. A description of the data. So I'm looking at soils data that was collected for the purpose of forest land taxation. Now, if I'm a soil scientist, that may or may not be relevant, right? It tells me it was following the National Soil Survey standards. If I go to the soils literature, I go to NRCS's soil surveys, I can find out that they have a very specific methodology by how they collect and categorize soils. So that tells me that this may be valid depending on my question. I also know that soils data is collected by sampling. So they don't look at everything in a field. They look at one site or two sites, and they may put 10 or a dozen sites in a sub-watershed. So then you have to say, well, how do they fill out the soil data between sample sites? Do they extrapolate? Do they make inferences based on what they see? How does that work? So we at least know that the data is valid because I can look at how it was collected, but we also have to ask questions relative to our question. There's some good stuff in there. When I look at the extents section of the metadata, and this is right out of the DNR data, it's missing. Oops. And I also see some things that talks about resource constraints, which is also very helpful if I'm trying to evaluate this data and ask how good it is compared to mine, so I get an idea of how accurate it is. And unfortunately, metadata is mostly pretty boring. I have field names and a number and widths and precisions and very technical stuff. Takes a lot of digging through that. However, then I come to a field called Major Underbar Species Underbar Site Index. And it tells me that this field is a misspelled index for the first major tree species. So this is starting to look at tree heights. Depending on my question, this may be a legitimate field that I want to look at. But in this case, they use 50 or 100 years. Other folks that look at tree heights use 100 or 200 years. And this also tells me that it's primarily west side conditions and east side conditions are treated differently. So if my question is about riparian zones and what trees and heights should be there, maybe this is relevant, maybe not, depending on the decisions they made. So that's spatial data, which has data standards fairly well sorted with the FGDC metadata standards. However, as with all standards, those are minimums. And I just want to say before moving on to a different data set, you will see data sets that are very minimal and don't tell you everything you need to know. So you want to find data sets that are more than minimum and go the extra mile to tell you how they did everything. Another data set that we might look at might be water quality data. And here's EPA's water quality data portal. They have a download. and there's nothing that says metadata here. So what do? Well, I start poking around and I find this thing called Getting Started Fact Sheet. And when I look at the fact sheet, I see location parameters, bounding boxes. This is the piece that was missing in the DNR data. I'm like, wait, this is data about their data. So maybe it is metadata, right? And as I dig into this Getting Started file, I see the fields related to the data that they use. I see one that's called result value type name that tells me the process that the data was used, actual, estimated, or calculated. Maybe I want to know something about water quality data in this certain reach, and maybe there's values in that field, but the code is estimated. Like, did they really measure it? So maybe this data set's valuable to me, or maybe I can filter the data set and get to the actuals and use only that data that was actual. So it takes a lot of digging, it takes a lot of sleuthing, but we can get there, maybe, depending on our question. So at this point, we're kind of through the elements of data quality, and we're kind of through what metadata looks like in its various shapes and forms. So I'm going to hand it off to Levi, who's going to actually walk you through an examples with a specific question, starting with how turbid is our surface water. So Shauna, I think you need to change me, or do I change that?
I can go ahead and change that. So Levi, the presenter baton is coming over to you.
We're only doing one handoff, trust me. This is much easier.
Okay, can everybody see that?
Yes.
Yep, you're good to go,
Great.
Levi.
Great. So like Brian said, I'm going to walk through just a few sort of examples, sort of baby case studies of how this comes up in sort of themes that are related to what districts are up to. Some of these are sort of projects and connections and things that are related to, say, VSP or prioritizing BMPs related to natural resource concerns. And so often there's, people are using information to prioritize how they're going to do things. And I wanted to just kind of capture a few of those to sort of use as an example for how to kind of filter that information to make better use of it and have more confidence in it. So we'll start with surface water turbidity, because that's something that seems like a lot of regions across the state are focusing on. And so here's the diagram that Brian mentioned earlier, kind of gives you the best practices as far as what to look for when you're thinking about data. So we'll start with the Washington Department of Ecology's online environmental database. It's pretty slick. There's a freshwater version of it where you can look at a map of stations. First thing to note is that, it's Washington Department of Ecology is itself a well-respected source of information. They're sort of focused on water issues, so we have confidence that they're using the kind of data and methods that we would want or wish for, and the information we're using. And there's quite a bit of documentation about how things are done. Compared that to the National Water Quality Monitoring Council, it's also an online database. You can also search by map, by county, by state, but this is a collection of information from a bunch of different sources. Could be a county, could be a state, could be a tribe, could be a nonprofit. I think a lot of projects that get federal dollars through grant money oftentimes are required to input their data in this. So the advantage is there's maybe more data than ecology, but you have so many different sources of information that was collected in different ways. It's important. It turns out to be important, and as far as operationalizing that information for decision making. So what I mean by that, here's an example of some data downloaded for one of the counties in Washington. You can see there's dissolved oxygen, turbidity, you know, just kind of typical suite of water quality monitoring parameters. And below the little methods box, you can see there's some acronyms. They talk about using a Secchi disk for depth and a dissolved gas supersaturation approach for dissolved oxygen. But there's a few of those records in this example that don't list any of that, right? And actually, when you look at the whole spreadsheet you get for an individual county, there might be, you know, 30% or more of the records might actually not have the method they use, so it's sort of lacking metadata. And so it's sort of hard to have confidence in using that information to operationalize your projects and programs. Like Brian highlighted before, you know, how the data was collected, it was an estimate or was it actually measured? Those kinds of things actually can really affect your conclusions. And another aspect of this is, you know, turbidity is the example here. We also have total suspended solids, which is very related to turbidity, but not the same. The units are actually different. And even the units of turbidity, there's NTU and there's also NTRU, which we'll talk about in a second. But it seems like a small nuance, but actually that can have a big effect on how you interpret the information that you're getting. So here's another example of that. This is actually from Department of Ecology's data set. Again, we're interested in turbidity. Maybe it sort of depends on what our question is, right? So turbidity and suspended solids are related. They're not the same. They use slightly different approaches. And so getting back to like, what is your question? Are you just sort of needing a ballpark idea of what are the turbidity patterns in a few of the different watersheds in your focal area? Or are you trying to get into real details about turbidity trends in a specific reach, for example? And so, you know, this is just sort of digging into that a little bit more. I can't really see here. Just the different units, right? So NTU is sort of the more standard turbidity metric. It stands for nephelometric turbidity units, but there's also a nephelometric turbidity ratio unit, and there's also Jackson turbidity units. And these are in both of the data sets, right? And they're measuring sort of different things: turbidity, total suspended solids, or suspended solids in concentration. This is the face that I make often when I encounter this stuff, because it does take a little bit of metadata and exploring it. It isn't super exciting. It's a little boring in a sense, but it's also sort of critical. So oftentimes I make the face just briefly and then move on. Again, just kind of digging into the detail just a little bit. It's like, what is turbidity measuring? It's measuring light and how light sort of travels through. And so more cloudy liquids, light travels not as well, versus total suspended solids is actually measuring the mass of suspended solids. So if your question is related to cloudiness, maybe you can use turbidity. If your question is related to sediment transport and stream geomorphology or something, maybe you're more interested in knowing what's suspended in terms of suspended solids. And sometimes you can actually convert between units. So maybe some of your data is in NTUs and you want to convert to suspended solids or vice versa. Oftentimes there are equations or there are studies or things in your region that will help you based on your soils types or other kind of parameters, help you kind of figure out if you can sort of standardize that. Again, getting back to what your question is, how detailed or specific of an answer do you need? The other thing to keep in mind is some units are more sort of regulatory oriented, and so sometimes you'll find some data is collected in a certain approach with this certain units because it's for regulatory, but it may not actually be from answering your question point of view, the kind of information that you want. The same is true for fecal coliforms, which are used a lot in water quality information, although I feel like folks are moving away from that a little bit, just because oftentimes it's not the best indicator of what's going on. But in this case, even just the approach, so they're all reporting fecal coliform sort of levels in water. One is an actual count of the bacteria on a plate, and the other is a statistical probability of bacteria in this sample. And for the most part, you really can't convert them because of that. They're so fundamentally different in a sense at some level that you run into issues trying to be able to convert one to the other. So again, just thinking about in terms of how you're going to set up your own monitoring, these kinds of questions, like what approach, what method, what units, do I want to do that in a way that will allow me to compare with other groups or other things that are happening in my county, or does it not matter? Do I want to choose a unit that's less sort of in the regulatory realm than the other? And those are things that you can kind of start to tease apart as you get into some of the nuts and bolts of this. Here's just another way of kind of assessing quality. This is from Ecology's database. They actually put in different levels. So level 1 is, hasn't been verified. It's like take it with a grain of salt. Level 5 is you could use this in a peer-reviewed science paper. And so you could go through when you get your information, depending on what your goals are, maybe you want to filter out all the level 1 information first before you start calculating things. And I can't tell you how many times I've been working on projects and you get data from another group or wherever and quickly do some statistics or math or something just to kind of get a sense of what's going on. Things don't make sense, and when you dig into this, you realize, oh, it's because half my data is level 1 and it's kind of messy, for example. So here would be another example for more kind of a mapping-oriented approach. I think a question a lot of folks ask, something basic like how much habitat for fish is there in this subwatershed or in my county, or we're thinking about applying for a grant for culvert removals. Maybe we should prioritize culverts that open up more habitat for fish. And one way we could do that is go to USGS. It's a well-respected source that have decades of great science and lots of documentation. Here's their online viewer. You can get things like stream flows and temperatures and groundwater information. In this case, we want to be looking at streams, right? And so this is sort of what that looks like when you zoom in. You have a topographic map with some stream coverage. But what you'll notice is there's actually 2 stream layers. One is small scale, one is large scale. And when we're just kind of busy in our day-to-day activities, we may not think that matters that much, but it does in the sense of, is this data good enough for my question? So how good of an answer do I need about how much habitat? Is this just exploratory? Because I'm going to run it by a meeting of my colleagues and we're just starting out this project? Or is this, we're applying for a grant and we need to know some really specific information about our habitat? So this is that large scale data set at Peterson Clearing somewhere in Washington. And in our study area, we found that we have just about 3 miles of stream. So if we pull this culvert out, we could potentially open up 3 miles of streams. But actually, if we use a small scale data set, it's 5.5 miles of streams. Small scale is a little more detailed, right? It's think like big scale would be, large scale would be printing off state of Washington streams on a paper map. And if you had the really small scale, fine detail of streams, it would be really hard to see that, right? So this large scale is sort of less detail, useful for some things, but maybe in our project, we want to know more detail about how much stream is really there. And how do we know that? Well, we can get in, like Brian showed, there's a little metadata tab, and you can go in there and you got to dig a little bit, but it says it was originally developed, the stream layer, at 1 to 100,000 scale. So that's big for the whole country. And then they went in and did high resolution to kind of supplement that. And it goes on to say that it's different in Alaska, Puerto Rico, different regions and things like that. So just a kind of a data caveat, if one didn't think to do this and just downloaded the large scale data set and started doing their grant proposals and stuff with it, the information that is presented isn't going to be probably as accurate as it could be. And again, it's sort of buried. It's like you can get, there's that first metadata tab, and then you kind of go to a different menu. It's like a little journey. And you know, honestly, the font's kind of ugly in metadata, and the format is not super visually appealing. So again, making that the agony face from before sometimes, but it's for a good purpose, because really it is garbage in, garbage out, and it's worth taking the time to make sure that the information you're using is good quality and meets your needs. And in the case of this USGS stream data set, you can actually, you know, they publish this really detailed report about how this is all done. In a way, it's really kind of amazing what we can do with science in 2021. And it's sort of encapsulated in this document. So if you really want to know, you can sort of follow the threads and find something like this to help inform yourself about the caveats of what you're using. So another example would be wetlands. Wetlands is a lot of folks that I work with around the state at conservation districts are interested in wetlands and how healthy they are and what they could do in terms of conservation practices to sort of support the functions and values of wetlands. Again, we can go to the U.S. Fish and Wildlife Service. It's a well-respected source. They've been around for a while. We can get on the online map viewer and pull up our area of interest and sort of map things. Wow, it looks like there's cool wetlands in this area here. We want to maybe compare because we're thinking about where we're going to install some BMPs, and we want to know, should we put it in an area with more wetlands or less? Well, can we use this data to compare that? I think it's useful in that sense, right? You can kind of see, just looking here, one area seems to have more wetlands, the other has quite a bit fewer and a little bit of a stream system. That might help you. Maybe you need to do a field visit to kind of verify, right? Well, how was this data actually created, though? Where did it come from? How much confidence can we have that these map wetlands are in fact really wetlands? And so here's where you kind of go down the rabbit hole of links. Here we go to data limitations. It says it's based on vegetation, visible hydrology, geography. There's some error inherent, kind of basic. Below that actually are more links. So if you follow those links, you can see, oh, okay, actually it was pretty much based on aerial imagery. They excluded some farmed wetlands. And moreover, the original report for the Spokane area is from the 1980s, and you can actually find that through that little rabbit hole. If you actually do sort through and start following links, you can actually find this report, and then you really know how it was done. And that's important because it was done differently at different times in different places in the state. And so here you can see that, when I go on in 2021 and download the wetlands data set from U.S. Fish and Wildlife and map it, it just looks like a single wetlands database, right, data set that you can look at. And that's great. It's super powerful to have that information. But when you kind of dig into it, some of the regions that data is from the 70s and 80s, and maybe hasn't been updated since then. And so it's good to take that with a grain of salt, right, and recognize that maybe more detailed analyses of wetlands using this data set is probably not warranted, but for sort of general purposes, it could be. So again, getting back to, is this data good enough for my question? I think maybe to compare, general comparison, help kind of prioritize where you want to do some field checks or think about which subbasins to put BMPs in might be useful for that. But if your question is, how have wetlands changed over time? Just going back to that map of when these wetlands were mapped, it's I think it's pretty tough to feel confident in that kind of analysis, how they change over time when you have data sets that are 30 or 40 years old. So it's sort of the apples and oranges thing that Brian was talking about. So we'll just kind of wrap up here with a few examples of other kind of critical area types. And it's cool because there is data free that's available online for us to get, but there are caveats. So here's frequently flooded areas from FEMA. These are digital flood rate insurance maps that were actually digitized from paper maps. And so there's actually some nuance in there that might be important to you. For critical aquifer recharge areas, we have sort of a groundwater atlas that USGS has created, but it doesn't have full coverage. It does have quite a bit of documentation, but the geologic maps aren't necessarily synonymous with a critical aquifer recharge area. You may need to add some areas of high risk or vulnerability or some more detailed hydrogeological information that you have in your county to help kind of supplement that. And again, so here's geologically hazardous areas. I believe this is from DNR or USGS. And again, it's like each of these quads around the state kind of has its own file that gives you the details. So again, depending on the level of information, if you just need a quick and dirty, I need to make a map, I want to show the basic themes versus we're actually going to do a pilot study and we need to know more about the geology so that we can set up our protocols more effectively. Maybe we want to use K factors for erosion. That comes from the Surgo database, also online. Well, how is that created? It's provided because it's one of the inputs in the soil loss equation. So it's related more to erosion and sort of ag, but there's caveats to that as well. If you click the buttons and follow the chain, you will discover it. Here for fish and wildlife, there's the priority habitat and species on the web, same deal. You can sort of look at the maps, get an idea for what's going on, but when you look into the descriptions, it tells you not every parcel's been surveyed. It's recommended that you do a field visit to kind of confirm things, and that the digital maps don't equal field conditions. So it's sort of like gets you in the ballpark for some questions that are kind of general or just a basic idea. It's probably fine, but if you want to do more detailed work or projects or programs that are related to having a better idea of what's really going on with butterflies or fish or raptors or something, then you can use this to sort of supplement that or guide your work, but maybe don't rely on it exclusively. So in short, there's a bunch of information, especially now with cloud computing and more data storage and sort of more science going on. There's a bunch of information online that folks also collaborate together. So like neighboring districts or neighboring counties or things like that. And it's important to sort of evaluate the appropriateness, I guess, of that information for what it is that you're doing. And really the best way to do that is through metadata, so that before you really start doing what you're doing, what to expect. I mean, sometimes you have sort of semi-garbage data, but everyone knew it because it was a pilot project and it wasn't meant to be super detailed. And sometimes that's enough. You just need to get a little further down the road. That's fine. The problem is when folks don't recognize that the data is sort of semi-garbagey and they really need good answers. And because the data they got didn't have metadata, they just assumed that it was good data. And then you can quite easily come to the wrong conclusion about what your natural resource concern is. Maybe the data showing that turbidity is a real problem, but actually it's because the data was messy and analyzed incorrectly, and maybe it's been trending the same, right? And the other issue is that metadata is often hidden in these links, and it takes some time to kind of dig through. And even when you find the link, it links you to documents, and then the documents is sort of hard to sometimes take some time and effort, I guess, to sort through. And then just one anecdote, I worked for a natural resource department once, and they had spent thousands of dollars for a consultant to go do culvert mapping. And there was a staff turnover, so the person who was running that for the department wasn't no longer there. The consultants who did the culvert work, I think, had moved on or moved to a different region or something. And I was given the data set. It was a GPS locations of all these culverts. It didn't have any metadata with it at all. And we couldn't, I tried every projection, coordinate system, transformation, everything on it. I could never get it, never matched up with anything, never matched up with streams. Or sometimes it was, half a mile away from where we knew it would be. And it essentially was completely useless. I was like hundreds of hours that people spent putting that together. And because it didn't have metadata and there was a time lag, it wasn't able to be used. So just a little encouragement to provide your own metadata too for the in-house data that you're collecting that you share with other groups too, so that it's easier to sort of assess how to use that moving forward. So yeah, basically good to document your information, where it came from, how it was collected. The idea is that you want it better than random, because that's sort of the purpose, in a sense, of data, is like to really know what's happening. Sort of the basic nuts and bolts of deciding that kind of relates to statistics, and it's if you're smart and clever about how you collect it, you'll be better off in terms of knowing the answer to that. Also repeatable, and it makes your decisions better because you're more informed about what's really going. What is the mirror of reality, as Brian said before, and how can you use that to better make decisions? Is ideal. So that's all I got.
Well, thank you, Levi, and thank you, Brian, for that great, for those of us who are not data nerds, which I'm not necessarily a data nerd, that deeper dive into how to scrutinize and be critical about data that you might need to rely on or want to rely on to answer a question, maybe data you are looking at for your long-range strategic planning, or you mentioned a voluntary stewardship program, right? This is sort of the place to be jaded and critical, is in looking at data. Thank you so much. Thank you. So folks, here's your chance for questions. Don't forget to use the questions box. If you have a question or a comment, you can raise your hand and I'll unmute you so that you can ask your question or share your comment verbally with Levi or Brian.
So Sean, while you're waiting for those to come in, this is Brian. I think just as a decision maker, the takeaway from this should be when somebody says, the data says this, your first question should be, what did the metadata say? And just as a starting place to have a conversation, because if you get a blank stare from that, you're in trouble. If they can start to tell you about it came from here and they did it this way and start going through the elements of good data quality, you can be comfortable that what they're doing is grounded in good practice.
Good point, Brian. Good point. So again, don't hesitate to raise your hand. Look for that little hand symbol on your go-to dashboard, or type your questions into the questions box. And just to make sure I'm not missing anything in the questions box, Alyssa, do you see anything coming in there?
I am not. Pretty quiet in the questions box right now.
Hopefully we didn't go too deep, but this was submitted, so the notes should be available. You can refer back.
Very true. We'll have a recording of this. You'll be able to look at the slide deck posted up onto Wade's website, especially if you had staff or fellow colleagues at your district that you'd like to watch this who didn't get to be in this session this morning. You can always send them to the Wade website later on to take a look. If you're questioning to yourself, I'm not quite sure I want to rely on this this piece of data I've landed on, or I'm not quite sure this is good enough to answer the question in my mind. Brian, Levi, can folks reach out to you for a quick, hey, what do you think about this?
Absolutely.
Sure thing.
Awesome. Awesome. So you guys have got the email addresses for both Brian and Levi up on the screen right now. Jot those down, take a quick cell phone picture, and those email addresses are up on the commission website as well. If you ever want to reach out to Brian or Levi and run a data question by them.
Hey, Shauna.
Yeah.
We did get a comment come through in the questions box, which I kicked out, that says it's hard when the person presenting is not the person who analyzed. Then the presenter can't answer the where did metadata come from question.
I'll take this one, Brian. Yeah, it is challenging because you've had a breakdown in the transfer of information, and only the data was transferred and not information about the data quality. And so I think as a community, if we get better at communicating data, we also get better at communicating metadata, because data by itself is okay, but it leaves the big question about where is it on that continuum of good to poor. And I think just as a community and being able to show that our data is actually, or our conclusions are actually reflecting reality, we need to get better at asking the questions all the way up and down the data chain, if you will. And I know that's not an answer, and it does make it hard that the presenter doesn't understand. But I think, when somebody hands you a data set, you need to understand the pieces that went into it. Levi, any thoughts?
No, just that I think it's not uncommon for there to be a little disintegration between the folks dealing with data on a day-to-day basis and then the folks kind of making policy with it or presenting it out in sort of the public. And so I think, yeah, just communicating and try to couch things in terms of, this is sort of low confidence data, medium confidence, or high, even just basic things like that. And then the other thing too is just with maps too, is to be careful. I remember times where, you make a watershed boundary quickly in your office to just for one specific person. It's kind of like not an important decision. And then that map gets emailed around after it sits in someone's email box for a while for some other purpose. And because it doesn't have anything attached to it and it's a visual, people start to see that map as reality. So there's different ways that communication can kind of get gummed up, just to try to stay close to your group.
Looks like we might have a follow-up question from Renee. Renee, you're just self-muted now if you wanted to chime in there.
All right, so thanks. Yeah, this really applies towards VSP, but sometimes with CREP, that it is quite challenging because we are asked to be sort of a jack of all trades and be an expert on all things and learn vocabulary of anything and everything. I'm not. And so this is just a limitation on myself. Yes, I understand metadata. I understand how to find it. I do verify that things are okay, but can I respond to you guys on a state review panel on where exactly it came from? Hell no. I just don't. I mean, I can get that information for you and respond, but that's just another vocabulary that I don't have at the ready. And so it's challenging because as I communicate with county commissioners and all of the other legal folks and making sure that we are dealing with the right thing and producing the right products, it's challenging because I don't speak the data that you are asking for. Does that make sense? And so it's just this struggle on, I can understand, it's just this translation whenever you're speaking a foreign language. You can understand what folks are saying, but you don't have enough vocabulary in order to respond. That's kind of the conundrum where I'm facing. And I'm not quite too sure how to address that without looking like an idiot, to be frankly and honest. That's where I'm at. Thanks. Sorry.
It's okay, Renee. It's Brian. Yeah, it is. You know, we are called to be generalists and to know enough to be dangerous. I think that's part of what comes with conservation, because we are jack of all trades. Part of our intention with presenting some of what we presented today was to help with that, and it's practice. And you know, Levi and I dabble in data all the time. Levi more than I, and we become more comfortable with it. And part of why we chose to present this topic was to encourage more broad critical thinking of data sets and talking about quality of data sets and therefore how we can make better decisions. And so hang in there. Just understand there's a different worldview in the data analyst world. And, you know, just like when we're talking to different levels of the technical spectrum, from data collector, field technician to county commissioner, decision maker, we do have to reach up and reach down a little bit to try and understand the language of both worlds and be in that middle ground. So I know that's not a great answer for what you wanted to hear, but I'm just going to encourage you to hang in there and practice, and it gets better. Promise.
And just related to that too, I think, you know, there'll be some more trainings and workshops and kind of forums and opportunities to connect on more kind of, you mentioned Renee, VSP stuff. So I'm pretty sure those will include bits and pieces of what we've been talking about today, you know, in those trainings that will come up. So hopefully, like Brian said, with some practice and maybe some more opportunities to kind of engage collectively on these issues, we can, as a sort of conservation community, help iron some of this out.
We will be hearing specifically about VSP this afternoon with Bill Eller. So that session's due to kick off at 1 o'clock today. We had another hand come up. Bill Blake, you should just be self-muted now.
Thank you, Shauna, and good job, Levi and Brian. Appreciate the presentation very much. Having been a nerd in the past. So I guess my question is at a big level, how you all are coordinating, because at the watershed level, we have our groups, like especially in shellfish districts, where we work with Department of Ecology, the Fish and Wildlife on their buffer analysis, Puget Sound Partnership on their progress measures and common indicators that go along with the Chinook recovery plans. The tribes have really good detailed analysis as they perform these days. So, you know, we're always trying to do peace, love, and harmony and work with those folks on the data they present. And so I'm just curious, at that higher state level, how are you guys coordinating to make sure on this metadata and the data so that we can know we're confidently, you know, and how we're doing things locally with those same agencies are, again, working together towards common things, but making it based on good data information. And when there might be something that changes, because, you know, we don't often see changes, but just a couple minutes on how that's all working at that bigger level to make sure we're all maintaining our integrity and doing the right thing.
Yeah, Bill, this is Brian. Part of that's just because as commission staff, we spend a lot of time poking our nose into the business that goes on around at different data collection efforts, and invite ourselves to a lot of things, partly because we have the connections to the folks, you all in the district's world, that have the connections to the private landowners, and therefore we can bring some value to the conversation. And then we are always interested in making sure that those efforts that other agencies and groups are doing and collecting are being founded in good sound structure, so that when there's a particular conclusion, we were in on the ground floor to say, yes, that's real, or no, that's not, based on how they set up their study design and their question. So I know I participate in a lot of the Puget Sound Partnerships, GIS discussions. We're involved in a couple of technical committees on the tribal efforts around buffer widths. We try to poke our nose into a lot of places, and because we are interested in how the data is collected and how it's being interpreted. I know Ron does a lot of work on the policy side for the same kinds of things, and so that's, in fact, we've recently been going through a set of goals and objectives and strategies for the Commission's 5-year plan coming up, and that was one of the areas we wrestled with, is like, why do we do that and what do we get out of it? And part of that is just to have a good sense of, again, the thinking and foundations that go into these data collection efforts that are being asked, again, for very specific questions and very specific reasons, and making sure that the conclusions are interpreted in the context of those specific questions and not being extrapolated out where they don't belong. And I'll end there.
Thanks, Brian. The questions box.
Thank you, Brian.
Write it down. Oh, sorry, Bill. Go ahead.
I just wanted to say thank you, Brian, for doing that. And anytime we can help too, just let us know.
Will do.